In this lecture, we're going to have an overview of the DevOps map, I guess, and introduce some concepts. So let's start by saying, where does the term come from? So it's a combination of the term DevOps and development and operations. And the original intent of DevOps was to break down walls between the two groups. So historically, developers would deliver completed systems to operations, and operations would then be responsible for provisioning hardware and running the system. And this caused tension because developers want to produce new code. That's how they get incentivized, and operators want to keep the system stable. And so you had tension between change and stability. Recently, the term DevSecOps has been used, and that the intention of that is to emphasize the fact that security should be considered in this process. So a more formal definition of DevOps from Wikipedia is that it's a set of practices that aim to shorten the system development lifecycle and provide continuous delivery with high software quality. And this definition ignores continuous deployment. So there are two terms that are appropriate here. One is continuous deployment. You, as a developer, commit your code. It automatically goes into production after going through the pipeline and passing tests. If it fails the test, you have to fix it. But if it passes all the tests, it goes into production without the interference of any human. Interference is maybe not a good word. Without the assistance of any human. Continuous delivery is automated testing, but the deployment decision is manual. And this is because there are some environments where a person has to make the decision to deploy something. And that makes them accountable for any problems that occur. And that's a result of some financial scandals that happened in the last 20 years. So if you look at DevOps, it's got three different facets. There's the technical facet, the organizational facet, and the cultural facet. For the most part in this course, we're going to talk about the technical facet. And this lecture is about as much as we're going to say about organization and, well, we may say a little bit more about organization and culture. And so if you look at the technical things, there are tools, there are processes, and there are architecture, and they all enter into speeding up the production and maintaining high quality. So just questions for offline discussion. Have you used DevOps tool? Which one? Does it fit the definition of speeding things up? These days, Kubernetes is considered a DevOps tool. Wasn't originally when it was developed. But how does Kubernetes reduce the time to production? What is there specific to Kubernetes that makes it easier for or faster for tools for systems to go into production? So let's talk about the motivation. So again, breaking down barriers isn't enough. It takes time and money to implement DevOps. And so the organizations have to be convinced that they will recoup their investment. And there are two classes of payoffs. One is reducing the time between committing the code by developers. So code complete used to be the developers said, okay, I'm done. Not anymore. And the placing of that code into production, deployment time. So you want to reduce that time. You want to reduce the time to detect and repair problems once it goes into production. That's called incident handling. So those are the payoffs that you get. And let's see the problems that cause the rise of DevOps. So this is the traditional process for constructing or modifying large systems. Developers are divided into teams. A new function or modification to an existing function is decided probably by the board if it's a big one. It's analyzed by the project management, and portions are allocated to one or more teams. Each team develops a portion according to their predefined processes and checks the results into a version control system. After all the teams have completed their portion, uh, the portions are integrated and a complete executable is placed into production. That's a traditional process. So what's wrong with that? Well, there are a number of sources of delay. First of all, defining the project processes takes time, and you want the different teams to use the same processes, possibly, at least the same technology. So you have to reach an agreement on a common language. What programming language are we going to be in? What versions of libraries are we going to use? So different versions have different characteristics. They may change an interface, they may change the behavior, the people that develop the libraries. What are the interfaces between the pieces? What are the tooling we're going to use? How are we going to coordinate? And so getting this agreement takes time. The meetings typically, even virtual meetings take time. And then you have to document the agreement. And then after you've done that, not all the teams will remember or abide by the agreement. Uh, there are delays in integration, incorrect use of interfaces, inconsistent library versions. I mentioned that. Inconsistencies in the development environments. So you're not necessarily sure that all the different teams are using the same environments. Uh, Integration can't be completed till all the teams have finished their portion and until all the third-party dependencies are available. So there are delays there. Uh, Testing. The testers have to define the test cases and the expected results. Manual testing takes time since humans are involved. Uh, you get errors in production. You have errors and you've set your configuration parameters incorrectly. You have problems with access control. You have inconsistencies between the development environment and the production environment. And so the time involved in deployment led to scheduled releases. So typically, historically, monthly, quarterly, or even yearly releases were common. And incident handling, once it goes into production, then the operator uh, either observes or is notified of some problem, performance, reliability, possibly functional. And if the operator was capable of repairing the incident, then they would do that. Uh, if it when it was repaired, there'd be a report. That report would go back to the developers, and the system would continue operation. If it wasn't if repairing the incident wasn't within the operator's capabilities, then they would write a ticket, and the ticket would describe the incident. It would get filed, and it would get routed to developers. And then the developers would take responsibility for repairing the problem, which diagnosing and repairing took time. Once the problem was repaired, it was probably included in the next scheduled release, unless it was really critical. And the next scheduled release would be months or week, depends on the release schedule. And the number of security breaches has been increasing dramatically year to year. And about a third of such breaches are caused by configuration errors. So you make mistakes configuring the firewall. Uh, Cloud systems and servers can be misconfigured, and so that can lead to security breaches. And so those are the kinds of problems that DevOps is largely solved. Uh, uh, and we'll talk about the techniques for doing that. And so what causes of delay in deployment have you personally experienced? How much time was spent identifying and correcting errors? Okay, so now let's go into the technical aspects a little bit. So if you look at the DevOps processes, and this is the life cycle, and we'll talk about the life cycle uh, uh, piece by piece here. So the first thing you do is you you design it. The design has to accommodate solution to deployment problems. So the design has to be set up so that you can do rapid deployment. And it also has to have visibility for monitoring and analysis. So you have to set up the design so that the appropriate type of monitoring and those results are visible. The design should be the subject of a security review. So security people will look at the design and say, what kind of attacks are possible? How are you preventing such attacks or repelling such attacks? Uh, DevOps automation involves a collection of scripts, and these scripts are typically developed and maintained by the developers. And you can also use static analysis to examine code. That's a static analyzer is a tool that looks at your code and said you shouldn't have, these are some problems with your code. And there are tools that can scan the scripts and look for various security flaws. And we'll get into all these things. Uh, so at build, you create an executable image once the code has been checked into the version control system. If you can't create the executable image for one reason or another, then it goes back to the developers. So maybe the interfaces are wrong. Maybe you mislabeled a particular method that you want to call. And tools can check whether any uh, components have any known vulnerabilities during the build stage, and then you do testing. And the test should be automated. Again, failed test returned to the developer. Uh, and you want to do both functional, does the system do what it's supposed to, and quality tests, how does it handle load, uh, what what are some security issues, is it usable, those kinds of tests are done. And then you decide to release the system into production. That can be done automatically based on passing the tests, or it can be done manually by somebody looking at the tests that were run and deciding whether or not those tests are appropriate and saying, okay, this system is good to go. And then you put it into production. So the executable image is placed into production. Access and authorization functions are in place. And then you operate the system. Users access it, the system performs its functions. You collect data about its operation. That's the important thing. You can also look at the network connections and their operations to test for security issues. And then you look at all the data that you had, right? That was the purpose of the monitoring. And you do an analysis and you say what can be improved. Possibly it involves making a redesign. Possibly there's nothing that can be improved. It's working fine. Possibly there's some modifications you can make. And so this may result in architectural modifications. And you go around this cycle again. And important in all this is the notion of environment, and we'll get into that. So an environment is a place where specific functions are done: development environment, the build environment, the test environment, and then of course the production environment. And it's a collection of provisioned resources. So this is the first time we've used the word provisioning. What that means is that you've loaded your virtual machines with the software they need, or your containers with the software they need. So these resources are provisioned, and they include an operating system, network connections, and then the hardware, memory and CPU, and then any software dependencies. So discussion again. Various stage of the pipeline should gather measures about their actions. What measures should be gathered? We'll talk about that in the end of the lecture, so you should discuss it quickly. What are some types of quality tests that can be done on the built system? So let's talk now about culture. So there's a, a lot of similarities and some differences between DevOps and Agile. The Agile people will claim that DevOps is just really Agile applied to deployment. DevOps people will say, no, the Agile people are worried about development and we're worried about deployment. And so if you look uh, at the focus of the two, they really are different. Agile focuses on management practices. So Agile worries about things like Scrum and Kanban and so on, short sprints. Uh, and DevOps focuses on tools. This is the deployment pipeline. It consists of these kinds of tools. This is the information that we gathered. And a good way to see that they're not the same is to look at how they generate feedback. So Agile gets feedback from customers. What should we do next? Um, are you happy with the way that it's working so far? And so on. DevOps gets feedback from the measurements that are taken. And are things working, operating the way they're supposed to? So the commonalities are both advocate a non-blaming, open sharing culture. You don't point fingers. What you say is there's something wrong, there's a problem, how do we fix it? Uh, and all members of the team should have access to the same organization. Communication channels provide for rapid sharing and feedback, and teams should be small. Uh, Periodic retrospectives are adopted by both groups where problems are analyzed. So those are the commonalities. But there are some specific DevOps practices that are different than Agile. One is the mindset. If you're a DevOps person, you're always looking for the opportunity to automate something. I did this twice already, and I had to do it manually. Shouldn't I write a script to do this? And so you're looking for automation and you're looking for monitoring and alerting. So DevOps thinks about monitoring. How are we going to monitor what we're doing? How are we going to alert if there's a problem? And then the second things are incentives. So Agile doesn't worry about incentives except develop code quickly. Uh, in DevOps is more organization specific, so the incentives are aligned. So I talked about the tension between the development team and the operations team. If the incentive is put in new code as quickly as possible with no failures, then both of the teams are aligned. If you're incentivized to do that type of, if that's your incentive, then that's the way you're going to operate. So the discussion questions. Uh, in your organization, how are developers incentivized? How are operators incentivized? Is there a tension between developers and operators? And who are the DevOps stakeholders? And who are the Agile stakeholders? And there's a difference. So let's talk about organization now. So in general, there's the concept of shifting left in DevOps, which means that some people involved in the early lifecycle phases, which specifically means developers, they're performing tasks that traditionally were done later in the life cycle. So you will see developers who are the first responders if an incident occurs, not the operators and things like that. And we'll get into this. And there's evidence that shifting left reduces costs. The earlier in the life cycle a problem is detected, the cheaper it is to fix it. And shifting left will cause changes in organizational units and moving sponsors. So if the operators have fewer responsibilities, then maybe you need fewer operators. If the developers generate tests, and again, we'll get into this, if the developers generate tests, then maybe you need fewer quality control people, or maybe the quality control group disappears. Okay, so there are organizational changes that come from shifting left. So the quality assurance unit may disappear or may shrink. DevOps practices cause for automatic testing, and that's why the quality assurance people who are in charge of testing may have less to do. Incident handling. Um, you may create a new unit to deal with incident handling. We'll talk about this when we talk about incidents. But Google initiated the concept of what's called a system reliability engineer, who are grouped into system reliability units, and those are distinct from the development units, and they are the first responders when an incident occurs. Uh, it's been adopted in other organizations. Netflix does it. There are books about it. Uh, System reliability engineer, and it's becoming reasonably common. Facebook created a unit to perform what they call production process engineering. And this unit's responsibility are to check the reliability, scalability, performance, and the security posture of production services. I haven't seen anything about that being adopted outside of Facebook. Sometimes there's a separate unit to create and manage tools because tools are important in DevOps. They have to be acquired. First, you have to decide which tools you're going to use. Secondly, they have to be acquired. Thirdly, they have to be maintained. Some organizations have units that actually produce the tools. Uh, so that's an organizational change from the traditional model. And responsibilities change. So traditionally, the operations group was responsible for ordering computers back when you bought computers instead of renting them. Now that the cloud exists, the resources are rented typically, and that is done by the developers. They decide how many instances they use, they set up the auto scaling rules to create new instances, and so on. So the procurement process of buying new computers is typically fairly laborious. Now, if you have a private cloud in your organization, then there still is a group that is responsible for maintaining that and procuring the appropriate hardware. And uh, one model for incident handling is you build it, you run it. Again, we'll talk about this. And this makes developers the first responders. So we have the potential for a separate group of first responders, or we have the potential of it being an added responsibility for developers. My, Microsoft and Alibaba have announced what they call the open system model, and that defines responsibilities for developers and operators in terms of platform-based tools. So developers build systems, they put them into containers. System operators, which is a new function, packages and deploy the containers, and the infrastructure operators pay attention to things like performance and reliability and scaling and so on. So are there other roles that are affected by shifting left, other than the ones you mentioned? Will the ratio of developers to operators to security personnel change as a result of shifting left? And so now let's turn to metrics. So DevOps is fundamentally a process improvement effort, the process of deploying things. We want to improve it. Uh, and if you have a process improvement effort, you have to measure it to find out whether you're improving. Uh, and are the changes you're making have any impact? So choosing the correct metrics is important since emphasizing the wrong metrics will lead to incorrect behavior. So there's an old Doonesbury cartoon where the pointy-headed manager says, "I'm going to pay people for every bug that they discover," and the one of the developers says, "Oh, great! I'm going to go code myself a Mercedes. And implicitly, I'm going to put bugs in that then I will find because since I put them in, I know where they are." Uh, and having too many metrics makes it difficult to optimize on any single one. So there's something called the DORA metrics, the DevOps Research and Assessment. And they propose the following four metrics, and these have been widely adopted. So if you only have four, you can monitor them and pay attention to them if you're a manager, and you can understand them. So it's a small number so managers can deal with it. Lead time for changes. How long does it take between committing a code change to the trunk branch, to the version control system, and when it's in a deployable state? How long does it take to go through the deployment pipeline? What's the change failure rate? What percentage of code changes require hot fixes or other remediation after production? So this doesn't include tests caused by doesn't include failures caused by the test caught by the test in the deployment pipeline. That was a tough one to get out. Uh, how many deployments into production per day, for example, per unit time? For example, Amazon reports thousands of deployments per day. Now, Amazon has lots of systems and lots of developers, and so these are not a single system that's being updated 1,000 times a day, but they're collection of systems. What's the mean time to recover? This has to do with incidents. So how long does it take to recover from some sort of service interruption or even a total failure? These are the DORA metrics. So discussion questions. How do you collect these metrics? Which organization role is interested in the results of each metric?